Hello and welcome to Higher Maths, Polynomials and Quadratics. We're going to have a look at what a polynomial is. So polynomials are expressions with one or more terms added together raised to a whole number power. So for example, we have 3x to the 5 plus x cubed plus 2x squared minus 6, or 2x to the power 18 plus 10. So the number in front of all of these x terms, those numbers are called the coefficients. And the x's are called the variables. Why is an x a variable? Because it can change. So x could take a variety of different values. So that's why it's a variable, because the value can vary. The degree of the polynomial is a value of its highest power. So this polynomial is degree 5. This polynomial is degree 18. And quadratics are polynomials of degree 2, because we may have x squared or 3x squared or negative 4x squared as the leading term. And constant terms or number terms are also polynomials, since 6 can be written as 6x to the power 0. So we're going to have a look at something called synthetic division. Synthetic division gives us an alternative way of evaluating for a given number. So f of 6, if we just substitute 6 into here, 2 times, or 2 multiplied by 6 cubed minus 9 multiplied by 6 squared plus 2 multiplied by 6 plus 1 would turn out to be 121. We can also do that using something called synthetic division. So we take the coefficients of f of x, so 2, negative 9, 2, 1, and write them across the top row of the table. If there's no term for a specific degree, the 0, then 0 is its coefficient. So say we just had 2x cubed plus 2x plus 1 here, we would have to write 2, 0, 2, 1. Right, next step, write the number for which you want to evaluate the polynomial. So we're finding f of 6, so we'll put the 6 at the front here. And then we're going to do a repetitive step coming up here. So bring down the first coefficient, so the 2 comes down, and we multiply by that front number. So 2 6s are 12, and we put that 12 in the next column. And then we add these two terms together, which gives 3. Then after that, we're going to do 3 multiplied by 6, which is 18. So that goes in there. 2 plus 18 is 20. Multiply by the front number again. 20 multiplied by 6 is 120. And then add these together, and we get 121. So the number in the lower right cell is the value of the polynomial for the input value. So this is essentially f of 6. This is often referred to as the remainder. So f of 6 equals 121, or the remainder is 121. So let's just have a look at one more example. So given f of x, evaluate f of negative 2. So again, write down the coefficients, bring the first number down, multiply it by the front, which is negative 2. Add these two together. Be careful with the negative numbers here. Negative 1 multiplied by the front would be 2. Add them together. Negative 20 multiplied by the front would be 40. Add them together, we get 0. So f of negative 2 equals 0. So this is a special case. This means that x equals negative 2 is a root of f of x, as the remainder is 0. So there's a little write-up about that here. So this means that x cubed plus x squared minus 22x minus 40 equals 0 when x equals negative 2. So negative 2 is a root of that equation. So if that's a root, then x plus 2 must be a factor of the cubic. And if x plus 2 is a factor, then we can factorize the cubic, because these values here, 1, negative 1, and negative 20, can be used to find the coefficients of the remaining factor. So f of x would become x plus 2, x squared minus x minus 20. Again, they come from here, and we're going to do quite a few examples on this in a minute. So multiplying out, just to make sure this works, we'll find that it does indeed get us back to f of x. So I'll do example 2 in a separate video.